Hey guys, I have something super special and funky for you today. 10-3 Operations with Radical Expressions. Before we do this, let's review how you combine like terms. If I'd given you 2x plus 5x, you would say, well, that's easy, Miss Barnum. All I do is add the 2 and the 5, and that equals 7x. Now, you didn't make it x squared. You didn't make it 7 2x or anything like that. Like, you just added the numbers. That was it, combining like terms. Furthermore, if I gave you this one down here and I said combine like terms, you would say, well, Miss Barnum, the only ones I can combine are the 2 and the regular x to make 3x. I cannot combine the 5 because it's x squared, and x squared and x are not the same thing. Ladies and gentlemen, that's what you're doing today. It's just that instead of x, we're going to put a radical sign. So I have a root 2, a root 2, a root 2. Pretend those are x's. If I gave you 3x minus 5x plus 4x, you would say the answer is 3 minus 5 is negative 2. Negative 2 plus 4 is 2x. Exact same thing. 3 minus 5 is negative 2 plus 4 is positive 2. The answer is 2 root 2. That's it. Okay, so on 1b, they're all 11s. Great, combine them. 6 plus 2 is 8. 8 minus 9 is negative 1. So you have negative 1 root 11s. Or, that's the same thing as just saying negative root 11, right? That's it. Now, sometimes they won't necessarily have like radicands. By the way, if you didn't know, radicand means the stuff underneath the radical sign. Okay, so if they're not the same, you can't automatically combine them. Okay, they have to be the exact same. They have to be like terms. Now, the bad part about these is that they're a little tricky because, actually, I think these are like terms. They're just sneaky like terms. Like if I take this and try and split it up, I believe a 4... Oh, no, I'm sorry. Let's try that again. Believe a 9 goes into that. Is that right? And the square root of 9 is 3. And the square root of 6, well, I can't do anything with that, so it's just 6. So this is 12 root 6. Now do the same thing to that 24. Looks to me like that's going to be 4 and 6. And the square root of 4 is 2. And I can't do anything with that root 6. Drop that 2 down. 2 times 2 is 4. Root 6. Don't forget this plus sign. Whoa. Wait a minute. Now you have like terms. Now you can combine them. 12 plus 4 is 16. Root 6. Okay? So to kind of do another example like that, this would be 4 and 3. Square root of 4 is 2. Whoops, still being multiplied by a 4, right? So that would be 8 root 3. Let's see, thinking about my square numbers, I think this is going to be a 16 times 3. I kind of was able to use a hint that I was like, well, this one ended up with a 3, so I think this one might end up with a 3. So 48 divided by 3 is 16. Wait, that's a square number. All right, so the square root of 16 is 4. Root 3. Bring down that 6. 6 times 4 is 24. Root 3. Bring down, let's see, this time it was a minus sign, so I'm just going to write a minus sign. And 8 minus 24 is going to give me a negative 16 root 3. Just like that. Real quick, they're going to have us review how we do these. Same thing as we did yesterday, where you're going to multiply the stuff that's on the outside together. So 2 times 7 is 14. Multiply the stuff that's on the inside together, so 6 times 3 is 18. Go ahead and simplify that if you can. This looks like a 9 and a 2. So that's a 3 root 2 don't forget that 14. And that 14 is being multiplied by that 3. 14 times 3 is 42 root 2. You already saw a little bit of that yesterday, so you can use this. That's maybe not as common when you're dealing with simple shapes like squares and rectangles, but when you get to dealing, especially in construction, where they want nice, pretty triangles that either have a 90-degree angle with two 45-degree angles, or a 90-degree angle with a 30 and a 60-degree angle, there's going to be some roots in that on the ratios of the sides. So you'll use this skill to solve for different sides of those triangles. You'll see it a little bit in geometry once you get there, so